and welcome to Group 12's video presentation. My name is Marcus, and with me are my group mates Wikit and Yising. Today, we shall present to you our project titled Friday, the Mini Social Board. We will first go through the project objective and scope, and project overview, following which we'll go more in depth in the main features of Friday, namely speech recognition and face recognition, emotion recognition, and object detection. We will then show you a video demo of Friday in action. Finally, we will present to you our findings and discussions. So, with many of us forced to stay at home in these difficult times during a pandemic, social interaction between friends and families have dropped. Reports have shown that this could be challenging to one's mental health. As such, the aim of the mini social board is to use AI technology to promote healthy social interactions for users and provide entertainment. Friday will be able to have voice command and use speech recognition to perform intent. It will be able to have face tracking and face recognition. It will be able to understand human emotion, and it can do common household object detection.
Hi everyone, my name is Wikit. Today I'll first start off by giving you an overview of our project. So we are using PC as the main controller that's running the system on Python. We have Arduino that's connected to several hardware as slave to interact with the human. And our user can start by activating our social board by triggering the wake word followed by the command. And through the speech recognition, we'll translate the speech into text to infer the intent. This is so to activate different modules respectively, for example, face registration, face tracking, recognition, or expression detection, object detections, and other functions like time and weather telling. So for speech recognition, our speech recognition is actually built on a background listener and an active listener. So we are using an existing lightweight acoustic model called the CMU Phoenix that's able to run offline and has very fast inference rate, which is perfect for a background listener because it is going to always listen in the background and always looking for a wake word. Although it does suffer a little bit on the accuracy, but it is good enough to use it as a wake word detector for a simple phrase like Friday. So once the wake word is detected, we'll then use the Google Cloud Speech API for active listening for the next few seconds. And this requires internet connection and runs slightly slower as compared to Phoenix. However, it does provide much more accurate translation. And from the speech translated, we can then apply simple rule-based system to infer users' intention by using keywords. For face recognition, we have our core hardware made up of Arduino with 2-axis servos for pan and tilt, a 5-megapixel camera modules, a LCD breakout panel for robots' eyes, LCD screen to show the recognized person's name and object, and lastly, we also need to establish the serial communication between PC and Arduino for data exchange. So for face tracking, we're able to do it by finding out the delta between the centroid of the face detected versus the center of the frame. But before we translate into XY axis motion, we actually divide it by a delta. We divide the delta by a ratio so that we only move the camera by a tiny little steps towards the general direction that it is heading. This is all for a smoother, to ensure a smoother camera movement. As for our face recognition architecture, which is built on several pre-trained models and a few of self-trained ensemble models. So first of all, the camera will capture the image, and then the face is being detected using face boxes. The face is then being cropped into 160 and 160 pixel, and then which then fed into the face net to convert it into 128 dimension feature vectors. And these feature vectors will then use on our self-trained deep neural network, support vector machine coupled with clustering method and cosine similarity and Euclidean distance, all this to make an inference to see if it is a match or no match between the target versus all the persons in the database. And then each individual model will decide who is the closest match amongst the person in the database. So from the 4 inferences made by the 4 models, we'll then take the majority vote and output a single person as a final result. And of course, each model has its own defined threshold to determine if it should be an unknown or a match from the database. So for deep neural network model training, we have manually gathered up to 66 different individuals or 350 face photos from social media. And this is all to generate 12K positive and negative cases from the training, from the pairing method that's shown below. And our deep neural network model architecture is actually a Y-shaped model, which takes in two input of 128 dimension embeddings, and output will be 1 or 0, as in match or not match. Right. And our second model, which we are using in Ensemble model, is support vector classification with clustering method. So based on the number of person registered in database, we can easily train up a SVC model, a support vector classification model for inference. However, we were unable to infer unknown person. So hence we're using this method to couple with unsupervised learning clustering method called HDB scan to detect outliers. So if it is outliers, then we will infer it as unknown. And if the target is not an outlier, then we will pass on to support vector classification model to further perform the prediction. As for our model performance, we are able to get approximately 73% of accuracy for each individual models. So combining the 4 models together, we are able to actually get an improved accuracy and F1 score up to 80%. And this validation is actually done on the separate validation set that are labeled properly with 9 classes made out of 8 persons and 1 unknown. So 9 classes in total that are unseen by the model.
Emotion recognition. Our team has used 3 sources of well-documented databases of human emotion images. They are the CK+ database, the Japanese female facial expression database, and the IMPAFace 3D database. We have utilized 5 emotion labels, namely angry, happy, neutral, sad, and surprise, and with an average of around 200 training data for each label. One might ask, why the low number of training data? Well, this is because there are not many publicly ready emotion images, and not to mention good quality ones. There is in fact another database known as the FER 2013, which we did not consider, as even though it has over 35,000 data, it is notoriously bad with missing or mislabeled data. For our training, we first need to extract the faces from our dataset, and we used 4 hard cascade filters from OpenCV to do so. Next, we resized the faces to 160 x 160 pixels and normalized them. We then append the emotion labels and create the train test split. Finally, we pass the sets into OpenCV's visual face classifier for training and run it for 10 iterations. So, in this flow diagram, we have the first step as the training process described earlier. Next, to enable real-time prediction with a camera, we capture the frame from the camera and similarly resize it and normalize. Then, we pass it to the model for prediction and print the emotion prediction over the user's face using OpenCV. On the right, you can see a short GIF demonstrating the 5 emotions being recognized. All in all, our emotion recognition performance was able to achieve an overall accuracy of 83.5%.
Hi, my name is Yising. So in this video, I'm going to talk about the object detection part of the Friday project. So one of our project objectives is to allow Friday robot to detect objects shown by the users. So in order to detect object effectively, I've chosen YOLO, you only look once, as our object detection algorithms. The main advantage of YOLO is that it is able to detect objects in real time, which is faster when compared with other detection algorithms such as raster, RCNN, SSD, and so on. YOLO comes with many different versions, and I have chosen YOLO version 4 because it has the best performance. I have decided to choose Coco dataset because it contains the right amount of classes for the indoor object. The diagram here shows the YOLO as a one-stage object detector, which consists of backbone and neck as a feature extractor and the head as a classifier. On the right-hand side, we have the example of the detection output inside my room. So next, a good data processing is a key requirement to create a good detector. Firstly, I have to prepare the target data for the item called lozenge by scraping the online images and capture the image using the webcam and phone. After that, I manually label about 250 images as the custom dataset. Finally, I have done some rotation on the combined dataset for the data augmentation purpose. After finishing the data processing, we have started to train the data using AI server, which consists of 4 GPU Tesla K80. By going through the transfer learning method, I'll be able to get the train rig file and test it on our Friday robot. So here is a flowchart on how I implement the YOLO detection in Friday robot. Firstly, the robot will capture the frames from its camera, convert the colors format, and resize the frame. And after that, it will use the YOLO algorithms to detect objects setting the threshold to 0.25. And then it will select the detected object within the focus area, filter out those unwanted noises, and finally it will stabilize the result output by choosing the most frequently detected output. So here you can see the quick demo on how the detection actually works. So on the left side, we have the system to detect the object including the lozenge. And on the right side, we have the system to select the largest object from the robot view. As for the detection performance, the mean average precision is around 58% with the IOU of 0.5. The F-score is around 0.6, which means that both the precision and the recall of the detector gives a good result. And here we have the graph shows the loss function, and we get the big file at the early stopping point, which is about 24K iterations.
Hi guys, so I'm about to show you the demo of our social bot Friday. So from the source code folder, you can start by running the main program Python file to initiate Friday. So I'm already in that folder, so let me just run this file. And it will take a few seconds to initialize. So once you see the vision window has popped up, then you are ready to start. And you can see that the face tracking is already working. Right. And the face recognition is also working in the background, but because I did not put my face onto the database, so it recognized me as unknown. So let me start by showing you the speech recognition. Hey Friday, what is the time now?
It is now 5:35 p.m. Have a nice day.
So Friday can tell time intention. So let me showcase the other intention. Hey Friday, what is the weather now?
It is broken clouds outside. Temperature is now 32 degrees Celsius.
So Friday can tell your weather as well. So like I mentioned, so at this point of time, the face recognition is already working, but because I do not have any face on my database, so it recognize me as unknown, which is correct. So for first-time user, you have to register your face by saying, "Hey Friday, register my face."
All right, registering your face. Get ready.
So you have seen the countdown timer on the vision window just now, right? And when the image is captured, Friday's eye will also blink to signify that the capturing image process has completed. So what we need to do next is go to the source code folder and go to face tracking package under the source, and the face that is being captured by Friday will be saved under this folder. So you need to what you need to do next is transfer this photo picture into this anchor folder. Right, create a new folder with your name, and then transfer the photo into this folder with your name. Right. And next, we just need to restart the system for it to take effect. I'll see you in a while. So I restarted my system, and then you can see now Friday is able to recognize my face. Friday is also able to detect your emotion, for example, like you are angry or happy. Next, I will show you how to do object detection. So I can switch over to YOLO object detection by saying, "Hey Friday, track my item."
Okay, show me the item you want me to recognize.
So under YOLO recognition, I can then show the item in front of Friday and be able to recognize what is it, and then display onto the LCD panel that we are seeing over here. Now we have seen how our face recognition, emotion recognition, and object detection work, and you're able to see the face tracking in action as I move my head left, right, and up, down. Friday will always try to capture my face and position it into the center of the frame. I hope you enjoyed the demo session today. Thank you.
Finally, the findings and discussion. As for the hardware cases, our budget is not enough to buy cameras with better quality, and the system processors are very reliant on GPU. For the emotions recognitions, we do not have enough good quality emotions images from public dataset, as our model could actually benefit from getting a larger number of data. For the future improvement, we hope that we have the mini CPUs to run all the processors with additional hardware such as the microphone, LCD panel, and so on. And we also hope that we can install moving bases with navigation system on our robot, install additional detection models, and install functions to monitor elderlies.